Let's talk about adding and multiplying vectors. So for this class, we will consider the x and y directions to act independently and be separate from each other, so that what happens in the y direction does not affect what happens in the x direction and vice versa. So this means that when we add vectors, we can add the x components together to get the x components of the new vector, and then we can add the y components together to get the y component of the new vector. So I'm just going to make some vectors here that I'm going to write in component form. So A is going to have components ax and ay, and B is going to have components not ax, but bx and by. And then what I really want to do is find some new vector c, which is going to be equal to a plus b. And because I am treating the x direction and the y direction separately, like I said before, the x component of my new vector is going to be ax plus bx, and the y component of my new vector is going to be ay plus by, and this will be the x component of c, and this will be the y component of c. Now we can also add vectors graphically, so I'm going to keep the vectors that I had before, a and b, and I still want to add a and b together to get c. So I'm going to set up some axes here. And when I add vectors, I draw my first vector first. So I'm just going to draw my vector A here. And then, because as long as I keep the direction and the length of my vector the same, I can move it anywhere, I'm going to draw my second vector, vector B, at the tip of my first vector. So I'm going to draw vector B out that way. And then when I'm ready to draw in vector C, I connect the leftover tail to the leftover tip, and that will give me vector C. And of course, if I'm adding more than two vectors, I just keep drawing them at the tip of the vector before, and I wait until I've added them all together to get my vector C. Now we can see that if I drop a line down here, and this is the x component of A, and I drop another line down here, and this is going to be the x component of B, that if I add those two things together, I will in fact get the x component of C. And I could do something similar in the y direction. Now, finally, we want to talk about multiplying by a scalar. So for instance, if I was going to take some scalar k, and remember a scalar just has an amount, it doesn't have a direction, and I wanted to multiply it by my vector A, I have to remember that I have to multiply k by each component of A. So this would really give me k times my x component, comma k times my y component. And finally, it's extremely important to remember that in this class, we will not be multiplying vectors by each other. That is beyond what we are capable of doing in BC Calc.